Hello. So what the driver hub is, it's just a phone running the Android operating system. So this could be on your Samsung phone, for example. So on that, in the beginning of Autonomous or in the beginning of Teleop, we would press the button saying to start the Autonomous program or to start the Teleop program, which we have to do because FTC doesn't have a central system starting all of the autonomous codes at the same time. We need to do it as the timer rings out during the game. So what the driver hub has the game controllers connected to it. So we would have the driver hub and the game controllers next to us during the game. And when we send that, like the signal from the driver hub to the control hub to start the autonomous code, for example, it's sending the signal to the control hub, and on the control hub where the code is hosted, it will do the calculations of, oh, I need to go 5 inches forward, and so on and so on. And on the control hub, we would have things like servos, motors, and sensors, and all the electrical and mechanical parts are connected to the control hub. There's also USB ports on the control hub, which allows us to attach things like cameras to it, so we can do vision during the game. Here's another picture of how the code is transferred. We have the driver hub connected with the game controllers, and the driver hub and the control hub are talking to Wi-Fi, saying, for example, in Teleop, if I move the joystick forward, it'll transmit that data to the control hub, and on the control hub, it'll process it to say, oh, move the drivetrain forward. And then on the right, there's also the expansion hub, which you can think of it as another control hub. It's just more ports for you to put on the robot. So when coding, we import things called libraries into our code. And these libraries add additional functionalities to your program. This means that it could be just a simple math import to allow you to do functions like absolute value or anything else. Or it could be things like vision libraries like OpenCV, Vuforia, and TensorFlow. Those allow you to create your own pipeline, what it's called. A pipeline is how you detect things, the code that you make to detect things. Those three libraries allow us to code those vision pipelines. And you can import multiple libraries into your program, so you can use as many functionalities as you can in your code. So if we talk about what the programmers need to do, we need to create reusable and modular code. This means that you shouldn't have one function and another function that do the same thing. You should have one main function that actually does the thing you're looking for, and then access only that instead of having multiple functions in your code. And during autonomous, this could be used to make efficient paths and multiple paths. Having efficient paths is saying that I want to score the most points possible. This is useful, but you also want to have multiple paths, as you want to communicate with your alliance partner before the match, saying if our autonomouses collide. So if they do, you need to have multiple paths to work around it. So programming that beforehand in a competition allows for less errors and less rush during the competition. So that adds into collision prevention, that we need to talk to our alliance partners beforehand. So next in Teleop, we need to work with the drivers to create intuitive controls. This would be saying that we would ask the drivers to say, how do you want the arm to move? Do you want to press a button to do that? And if you want the arm to move to a specific position, for example, you can't just the driver, we have to put in the code an automated feature saying that I want to go to this position in the elevator. And instead of, without having automated features, the drivers would have to use like a joystick or something to keep adjusting the arm's height. So having automated features allows us to not waste time during the match. And as I was saying before, we need to have consistency in our programs. And this could also be applied to organizing your code correctly. So one file, you would have your ARM functions, and another file, you have your intake functions. So you want to separate them so it's easier to find and edit if there's an error or something new you want to add. I'll be talking about having more functions and classes later. So here's an example of the programming team, our team, FTC 1.4 and 3, talking with the drivers and seeing what buttons they want to do for the different functions on the robot. So you can see on the top right, we said that the trigger button would be toggling the intake. So that would be an automated feature of saying, make the intake go to this position and this position, a toggle. That's what it's called. So during autonomous, we want to move the robot around, obviously, to score points. But to do this, there's two basic ways of doing it. There's time and encoders. Time would say that I set all of the motor powers to 0.5, half speed, and we're going to move forward for 5 seconds, so add a sleep for 5 seconds, and then stop the robot, setting the power of the motors to 0, no power. So it's good, but it's not really, 5 seconds isn't really a measurement of distance. We know that it's 5 seconds forward, but what is 5 seconds forward? We can calculate that and instead make it so it's the code says go 5 inches forward. This would be saying using the circumference of the wheel and creating a ratio of saying, well, if the one whole revolution of the wheel goes X distance, what will 5 inches, how many revolutions will 5 inches be? So we can calculate that, but so it's easier to code and know where our robot is during autonomous. Right. So now, if we I'm going to go into Android Studio and talk about how this works. So if this file is the test intake subsystem. So subsystem is the part of the robot. And as I was saying, you need to separate those parts of the robot. You need to separate the subsystems so it's easier to code later and while we're coding. So in the test intake subsystem, if we look at the first line, it says package org first inspires blah, 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 blah. Package means, and then that list means where the file is located. So if we look at the file system, it says learn Java and then system. And then if we look at the package, it says learn Java and system. If you're in run motor, it would say just learn Java. It wouldn't say system. So if we go to run motor, this file right here, it would say just learn Java. So package allows us to know where our file is located. Then if we look at our third line and so on, our import statements, these are libraries. So what I was talking about, the functionalities that you're putting into your code. So these three libraries are gamepad, hardware map, and servo. I'll be talking about hardware map later, But gamepad and servo, those allow you to control the servo on the robot and get data from the gamepad on the driver hub. And if it says com.qualcomm.robot.core and then the rest of that, that shows that it's provided from FTC. This means that we don't need to download anything into Android Studios that's on the robot because it's already downloaded. If we were to use something like an external library that another team made, for example, we would have to download it onto the robot, then we would be able to import it into our code. So then if we look at public class, this means that it's a class, it contains functions, and it's public, meaning that any of the files in the file system can also use the functions inside of the class. So, and inside this class, we have our variables here. So, if we look at our first one, static servo intake, this creates an object of our servo on the robot, which in our robot, in this, assuming by this code, our intake is controlled by our servo. So that's why we imported that servo library, and that's saying that this object, the intake object, is type servo, meaning that it's a variable containing a servo. It's a servo variable. And then intake open and toggle intake also create objects, but that's for the toggle later, which I'll talk about later. Next, we have our next function right here, which is our constructor, which this constructor allows us, this runs before everything inside of the code. So when you import, you can import this file into another file like your teleop or autonomous file, and this would be ran when you import that. So that's the constructor. Inside the constructor, we want hardware map, which was an import from up there. So in that hardware map, we say intake is equal to hardware map.get servo and then intake. This means that hardware map, meaning what's on the robot is the hardware map. What's plugged into those ports on the control hub / expansion hub is our hardware map. And we're trying to find a servo, shown by servo.class, that is named intake. We name these ports saying that this is a servo port and its name is intake, so we can easily find it in the code. So once we found that where the servo is located, we say that the intake object we created above is equal to that, so that intake object is controlling that real servo on the robot. Then, if we scroll down, we have the function update intake. This update intake would specifically be used directly be used during autonomous. So in that, we would have saying if the intake state is 1, when it says intake state, it's an integer, which is just a real number. And in that, we have, if they put in 1, it will set the position of the intake to 1. Then, if it was anything else or 0, it would be set to position 0. So it allows us to easily switch between the two positions in the code. So that would be doing autonomous. So example of us using this is if we open up an example autonomous, we say intake.update intake and then position 1, and then later we say position 0. So if we go back here, we see teleop. So in this function would be ran during our teleop sequence instead of our autonomous sequence. But in this, we don't, if you look at the code, we don't see anywhere that it says intake.setPosition. This is because we want to we don't want to v-write anything that can be easily written. So instead of saying copying this if-else statement right there and putting it right there, we can easily just use that function that we made before. So it's a more cleaner and concise code. So this if and else if statement is just a toggle. So this is because you want to use a toggle when using the buttons on the controller, because when you hold the button, hold the button on the controller, it's gonna send just true values to the to when you click right bumper, it's gonna send true values. But if you're always holding the true button, the right bumper button, it's gonna just keep returning true, and you're gonna keep updating the intake to be open, close, open, close, open, close, and it will just like shiver. So that's why we're gonna have a toggle saying that you press it, and if you still if you're still holding it, it won't do anything. You have to let go and then press it again to close it or open it, and whatever based on whatever action you did before. So that is shown by having the variable toggle intake, which we defined up there, which is Boolean, true or false. And when toggle intake is true, we say that now it's false because we're holding down the button, and we're also setting it to false when we're actually pressing the right bumper. Then we say intake open, and then intake open times -1. This is just flipping the symbol, so we don't have to say if 1 set to 0 or if 0 set to 1. It's just an easy, quick way of saying flipping the symbol, the symbol of intake open. So intake open is saying that what is the position of our intake. So we put intake open into our update intake function, and in the update intake function, we would say, is it 1? Okay, set to position 1. Is it anything else? Or if it's -1, it's going to set to position 0. Then while the right bumper gamepad is not pressed, we're going to set toggle intake back to true, because then next we can press it again to close or open the intake. So that is the general basis of intake subsystem, and just showing that the update intake is a state machine, while the teleop function is a control loop. So this control loop loops again and again, while that is just a function that is called like once at a time. So next, if we see where this intake subsystem is used, we can go as an example to our teleop file. In our teleop file, again, we have our package. This is saying where our robot is located. Then we have our imports. Then in the imports, it shows that teleop, we import teleop. And teleop is used when you say @teleop and then all of this. This shows that this is a teleop file saying that it's going to repeat again and again, and it's named test teleop, and it's in iterative op mode, another way of saying teleop. So on our driver hub, if we click the iterative op mode button, it's going to show a list, and in that list, there's going to be a file named test teleop, as we said @teleop there. Then we say public class test teleop. That's creating the class of the test teleop. just like we did over here. But this time it says extend to op mode. This is telling this file system, the driver hub, that this file is not just does not just contain functions. This file, what? Thank you. This file is an op mode, meaning that it's autonomous or teleop. So it allows you to differentiate between the normal classes with functions and the classes that are op modes. So next we could say we're saying private test arm subsystem arm equals null. This is instantiating the arm function, creating an object of it, saying that our arm file that intake file that we've made up there, back there, is we have it contained in this variable, and down here in our init sequence, this is what's running once, is once in the beginning of the autonomous cycle. We're instantiating the object, giving it hardware map, saying that this motor port 1 is named intake, and we're going to be, servo port 1 is named intake, and we're going to use that. So next, now that we have instantiated our intake subsystem, we go into our loop. In our loop function, notice that it says at override here. This is because we're not actually going to be using running these functions. This is because it's automatically ran when we press start up the code on our driver hub. So we don't want to import the teleop file and see our loop functions, because it's not going to be actual functions. It's not going to be actually looping. Our driver hub handles are the looping and all that. So then we use our teleop function that we've made in our intake file. So if we made this teleop function here, we're just running that again and again in here. So this full system without the ARM, that's just another subsystem that I've created. It's basically going off of the same stuff, just lots of repetition. But this teleop system would open and close the intake like we've made inside the subsystem. And if we go over our auto sequence, we see that we have our package function, and then we also have our library function, library imports, which this time is linear op mode and autonomous. The linear op mode shown here, just like we extended into op mode here, this time we're extending into linear op mode. This is another word for autonomous because it's linear, it's just running once. So, and then we're also stating that it's an autonomous file and it's named test auto and it's in group auto, autonomous. So when we go to the auto dropdown in our driver hub, there's going to be a name called test auto inside of it. So next, we again instantiate the ARM and intake. And then in here, in auto, well, it's permitted to use sleep statements. We only use sleep statements because instead of saying drive up and then using sleep statements says that we can drive up, wait a second, and then place some cone or pixel or whatever game piece we have after 1 second of driving up. This is important to use the sleep statements, because if we just quickly drive up and then quickly place our game element, we might still be moving, as when we say motor.setPower 0, it sets the power to 0, but it doesn't like press the brakes onto the motor, because it just turns off the power, so it's just drifting a little. So that's why also some teams use odometry, which allows us to control the position of our robot over wherever it moves, record the position of our robot wherever it moves, which our team is in the midst of coding. But if so in this example, we had opened the intake using intake.update intake, wait 2.5 seconds, that's in milliseconds there, and then move the arm to position 3, which is, we don't need to worry about the arm, and then it's going to wait 2.5 seconds, and then it's going to close the intake. So this could be autonomous if you want it to be, but rather doing it autonomous, you would be moving around. So an example of one of our old autonomouses, well, this will be more old, but that's all commented out. We would say rotate and then what's it called? Move forward or backwards. This was old, meaning back then with our drivetrain, we had 3 functions. We had one function for rotating in place, one function for going forward and backwards, and one function for strafing left and right. But rather, a better way of coding your drivetrain is making a function that can mathematically calculate where our robot, what our powers for our wheels have to be when we can say example of moving at 45 degrees at half speed at of 10 inches. So if we create a function like that, which I don't have it open right now, it's easily available to code in autonomous. So it's just easy. You have to input your angle, the distance you're going, and the speed you're going at. So that is an overview of the code. So, and I was talking before about the vision, and the pipeline. So an example of using the pipelines could be, where to go? Yeah. So this is an example of a pipeline. So you say where it is, and then you import all of your libraries. So in this one, rather, it's going to say org.opencv. This means that it's not directly from first. This is from OpenCV. And what we're importing things like core, mat, rectangle, and scalar, which just allow us to edit the picture, our frame that we're getting from the camera. So when we run this, this pipeline specifically that I've made splits the average colors for of the camera. So if we have a picture like this, and if we switch to the pipeline, it's going to average out the colors of the picture. So this would be useful in our game, in the FTC game this year, because we're trying to detect where our team element is located. So using vision allows us to do that. I won't be going too in depth inside the code exactly, because that's getting more complicated into actually coding vision. But that's pretty much it for today. But thank you. I have a YouTube channel, Beyond the Bot, and yeah. Yeah. Thank you.